Okay, hello, my name is Emilio Martinez, and this is my teammate, Eugenio Guevara, and this is our calculus final project. And this is our topic for this project, the integrals of secant.
So this is the first problem. We chose this problem because it has a secant with an even exponent, and to get the answer we need to use a mixture of integration by substitution and trigonometric identities. Okay, so the first step is we're gonna split secant to the fourth power, so it's easier to work with. So it's tan 6x sec . Okay, now we're gonna replace secant squared with its trigonometric identity, which is 1 plus tan squared. Okay, so now we're gonna start the process of integration by substitution. So our u is tan, and the derivative of this is secant squared, and now we're gonna replace it here, so it's 1 plus tan squared, and we rewrite that here, so it's sec 2x, and we change the dx for du. So we eliminate this sec squared with this one, and this one is u because it's also tan. So now we multiply this, which is u6 plus u8 du. Okay, so now we're going to use the basic integration formula, which is this one. So we add 1 to the exponent and we divide it by the same number. So it's u7 divided by 7 plus u9 divided by 9. And now we substitute the u for the value. And this is our answer.
Okay, and this is our second example, and this example is different because this is secant with an odd exponent. And if you have an odd exponent, you're gonna have to use the integration by parts to solve the function. So the first step is to split the secant into a normal secant and a secant squared. And we're gonna use integration by parts, so we need to get our variables, and our u is gonna be secant, this normal secant. Our du is secant x tan x dx, because this is secant just formal, like differentiated. And then our dv is everything else, so it's secant squared dx. And our v, which is secant squared integrated, is just tan x. Okay? And now we need to follow the formula, which is, if you remember correctly, un valiente soldado vestido de uniforme. That's the formula we need to follow. So we do u and times b, so it's secant x times tan x minus the integration of b and du. So it's going to be secant x tan squared x dx. So now we just need to solve for this integral. Okay, so this is just the same thing, minus, and we're gonna replace tan squared with its trigonometric identity. Okay, and we multiply and then separate it into two integrals. I'm just gonna do it in one shot. Secant x tan x minus, and it's gonna be secant, I don't need this, secant cubed x dx minus secant x dx. Okay, and we just need to simplify this and remove this part and finish this part to finish the problem. So I'm gonna erase everything. And we were left with sec x tan x minus secant cubed x dx minus secant x dx. Okay, so this one we can solve it normally, and there's a rule for integrating secant, which is just that the answer is going to be ln secant x plus tan x. So that's that. We don't need to do anything else with that, but we're gonna do some tricky stuff to this one. So our problem says secant cubed x dx, and our answer is this one. So this is equal to secant x tan x minus secant cubed x dx minus ln, and I'm just gonna do point because this is not the final answer, so it doesn't matter. And this is plus c. Okay. And if you notice, this one is the same as this one. So we're gonna use that to our advantage. We're gonna pass this whole thing to this side, and it's gonna change it to 2 secant cubed x dx, and this is equal to the answer. And then we're gonna divide everything by 2, thus eliminating any, okay, thus eliminating any integrals from the final answer, which is gonna be this one. And just a quick note, to be able to use this method, you need.
So our conclusion after working on this project from our favorite teacher is that we learned the differences of integrating secant with even or odd exponents.
The main differences is that with a secant odd exponent, you have to use integration by parts because it's not possible to resolve the function if you don't do it. And with an even power, you do integration by substitution, and it's way easier.